Hello, everybody. Welcome back. So we're going to take a look at when do we use law of sines, law of cosines in different situations. We begin with our do now problem. To determine distance between 2 points A and B on opposite sides of a swampy region, a surveyor must choose a point C that is 350 meters from A and 400 meters from B. If the measuring angle ACB was found to be 105 degrees, find distance between the swampy region to the nearest meter. Right, so, okay, so let's pretend this is our swampy region. Okay, and so we'll find in this case point A, and here's point B. And there's point C, somewhere over here. Okay, now we are told in this case that point C is going to be 350 meters away from A. And point C is about 400 meters from point B. And so we want to find distance between the swampy region. And the angle in between is going to be 105 degrees. Okay, so we'll find this distance. We'll call this distance between A and B X. Okay, so the very first thing is you got to read carefully and draw a diagram. The idea in this case is that that C was not going to be on on line segment AB because there was an angle 105 degrees between the in this case AC and BC. All right, and so we definitely want to start by drawing a diagram and labeling it properly. The next thing we'll do, we'll have some steps here for you guys. So here we go. Step 1, read the problem carefully. Step 2, draw a diagram and label it. And again, go back to step 1 if you need to, in case you are unsure if your diagram's correct. Read the problem carefully, and then try to draw a diagram. And then if you need to, go back to step 1 again, read the problem carefully. Now, I keep saying this because of the fact that a lot of times we're in such a rush to get the answer that we do not read everything. We don't read everything carefully. We kind of like zoom through things, which is probably going to be one of the big mistakes we're going to make. So I want to make sure that you guys understand that I would like for you guys to, instead of rushing through a problem, make sure you read the problem carefully so that you get all the proper information. Now, step 3, note the relationship of the sides and angles whose measures are given to the side or angle whose measures to be found. Okay. And so when we say this, what are we looking for? We're looking for a side here. And so for our problem, we're looking for a side. And of course, where is it located? Well, it's definitely located opposite the angle is given to us. But then also we want to figure out a relationship between the other piece of information we have. Choose the appropriate law and write in terms of the letters that were used to label a diagram. So we got to figure out which law to use. And we're going to get to that in a minute though. So once we decide based upon a diagram and which sides and angles we have, angles we have, we can decide, okay, so what is the most appropriate law to use? Of course, determine the required measure, meaning find the answer. And finally, step 6, does the answer make sense? Meaning in this case, will your side be will make sense if it's going to be the longest side of the triangle? Will it be, in this case, bigger than the other two sides, or vice versa? The smallest angle triangle will be the smallest side. Okay, so how do we know when to use law of sines, law of cosines? Well, based upon the information we have of the triangle, we talk about the same way we described different ways to prove triangles congruent. So here, we use law of cosines when we have a side or side angle side situations. Now side means we know all the 3 sides of the triangle but don't know any other of the angle measurements. Or if we have 2 sides measurements and the measure of the angle included in between the 2 sides, then it would definitely be law of cosines. We use law of sines when we have angle side, angle, or side angle situations. Being in this case, I have 2 angles and a side opposite one of the angles. Definitely, that works out for law of sines. For angle, side angle, we could find the third angle of the triangle and definitely have the angle opposite the given side we have. Or side angle, we have the measure 2 sides and angle measurement opposite one of the sides. So if you're not sure, Now, determine a situation where you have information about angles measure and the measure of the side opposite. So if you know the measure of an angle and you know the measure of opposites, if you do have that, then it is a law of sines we're using. If, however, you do not have a relationship between knowing the measure of the angle and the measure of the side opposite of that angle, then it's probably going to be law of cosines. Let's go back to our diagram here. Okay, so we have in this situation, looks like we have this side, and this angle. So this is a side angle side situation. Not only that, we do not know the measure of this, have a combination of an angle known and the measure side opposite known. So this is going to be the law of cosines. So here for law of cosines, we're going to use the following. C is equal to the square root of, now we know we said C squared is equal to, but I'm going to cut right to the chase and say we're going to take the square root of both sides. We're going to type this whole thing calculator this way. So in this case, C equals the square root of A squared plus B squared minus 2AB cosine of C. So here for this situation, we have 350 squared plus 400 squared minus 2 times 350 times 400 cosine of 150. So we'll break out a calculator and work these out before. So I'm going to just clear everything here. And so square root of 350 squared plus 400 squared minus 2 times 350 times 400 cosine of 105 degrees. Not 100, that was 150, it was 105 degrees. So I wrote an error there. I'm going to fix that on the board. So we're going to get in this case 595.7930283, or in this calculation, round to the nearest foot, this will be 596. So first, let me make a correction in this here. So not going to be 150 degrees. It should be 105 degrees. My apologies for that. So 105 degrees. But we said in this case, let's double check to make sure that our measurement C in this case, well, this is C, of course, X equals C, is equal to, I think we said 595.7, yes, 596 feet. And so this is how we find the measure of the side opposite, in this case, of an angle here. Now it's basically find the measurement between the swampy region, if you will. And that, sometimes is what surveyors do. Okay, so we have another situation, all right? Again, we take a look, we want to draw a diagram, we want to label it carefully, and then determine which ratio, which formula with law of sines, law of cosines, and this was definitely law of cosines.